All right, here's just a quick reminder on how to set up your notes. You should have the daily question and the date on the top, and that you're taking your notes in black pen or pencil. Make sure any new vocabulary words or concepts are highlighted in red in your notes. All right, let's get started. We're going to do a quick introduction to the scientific method. This is the process scientists use to answer a question. Because here in biology class we'll be using the scientific method frequently, I do like to spend some time at the beginning of the year practicing the scientific method, going through the steps and getting you comfortable with this process. I actually am going to change this just slightly. Instead of saying scientists use the scientific method, I want to put people use the scientific method. We may not call it the scientific method, but anytime you have a question and you come up with a way to find an answer to that question, you're actually using the scientific method, even though you probably aren't calling it the scientific method. I decided to give you some real life examples so you can kind of see what I mean by this. First of all, let's use an example for the guys out there. You've seen the commercials. You spray the Axe spray and all of the girls will come around you. Well, there's a way to test that. I wonder if that really works. Go to the store, buy the spray it on, and you see, do the girls come around or don't they? You've now conducted a scientific experiment and used the scientific method. Ladies, you might have seen a commercial that uh, advertises that if you buy this specific mascara that you'll have eyelashes all the way up to your eyebrows. And so you go and you buy it, you try it, and you see if it works or not. You are using the scientific method. I'll give you a quick example from my past job, and that was my job at the Fresno Chaffee Zoo. I worked there for about 12 years prior to being a teacher at Reedley High, and they actually used the scientific method there very frequently. And again, they didn't call it the scientific method, but they had a question and they came up with a way to answer that question. This particular question had to do with one of the female orangutans that were at the zoo. And this was about 6 or 7 years ago now. She was pregnant, and we were super excited because they are an endangered species, and so it was very exciting that there was a new baby going to be born. But just like all pregnancies, they needed to be monitored very closely. And to monitor the growth of the baby, the vet needed to use a ultrasound machine, the exact same ultrasound machine that we use on humans. Now, if you know anything about ultrasound machines, they project an image onto the screen here, but you have to use this little wand, and there's usually a big thick gel that gets rubbed on the belly so that the machine will work. Well, it just so happened that this orangutan didn't want anything to do with that gel rubbed on her belly. She refused to let the keepers and the vet get close to her with that gel. She did not like it at all. So the big question for the keepers was, how are we going to get images of the baby if we can't use this gel? So their first thing was to ask other zookeepers. They started making calls to other zoos. Had anybody else had this issue? And nobody else had. So they decided to just figure out some other things that they could smush up that would work like this gel does. Their first try was with bananas. And the orangutan didn't mind the bananas at all, but what happened was as the bananas got smushed, they became very liquidy and the machine wouldn't work anymore. So they realized that wasn't a good solution. So one day at lunchtime, the keepers were sitting around eating their lunch, and one of the keepers was eating guacamole. And she looked at it and thought, I wonder if this might work. So she took it over to the orangutan, rubbed it on her belly, and the orangutan was totally fine with it, and the machine worked. So here's an image of the keepers actually utilizing the machine with the guacamole on it. You can see the guacamole right on the end of the machine. And they were able to get these images. These were some of the first images they got of the baby orangutan. So with a little problem solving and with a little creativity, they were able to figure out an answer to their question. That's the scientific method. And here are the results. There was a successful birth, and it was the cutest, craziest looking baby ever. And actually, they have since had another baby there at the Fresno Chaffee Zoo. They're getting pretty big now, but next time you go, check them out. So here's what we're going to do next. I want you to create this chart in your notes. This is a very simple chart where we're going to talk about the steps of the scientific method and give a little description of what should be included in each of those steps. This is also how we're going to write our lab reports. Now at any time here as you're going through this video, feel free to pause it as you're copying this into your notes. You can always go back and re-watch it or as many times as you need to. And so I know I may be talking quickly, but remember you can pause it. All right, so step number 1 is called the background. Here's where you're going to write down what you already know about the topic, observations you've made. It could be from previous experiments or from readings or things we've talked about in class. And then you're going to come up with a question. What is the big question that you have about this topic that you want to test? Typically, it comes in this kind of sentence frame. I wonder, fill in the blank. I wonder what would happen if. The next step is to create your hypothesis. Now, all of you have heard of hypothesis. We often call it an educated guess. I like to call it a prediction. It's what you think the answer is going to be to your question. You're going to decide what the answer is before you even test it. Typically, a hypothesis comes in an if, then statement. If I do this, then this will happen. Notice it's a statement, not a question. Now you need to design your experiment. This is where the procedures step comes in. Here you're going to list all the materials you need and the experimental steps that you're going to take. This needs to be detailed because somebody else needs to be able to recreate your experiment if they ever wanted to. After you've got that all set, you will now do the experiment and collect your results. Results are all of the information that you gathered during your experiment. So that will be your data. That's called quantitative information. Those are your numbers, graphs, and charts and things like that. The second piece you want to record in your results are your observations. These are qualitative information. This could be a written description of what you observed. It could be drawings, and it could even be photographs. So these are all the things that can be included in your results. But I have found the most important piece that is important for your lab write-up, but also the one students miss the most points on when doing a lab report, is their last section, the analysis. There's a lot of information that needs to be included here. Here's what you need to have. Your first statement should be using your data to accept or reject your hypothesis. Were you right or not? And use your data to support it. What did you learn? Overall, what did you learn during this experiment? Were there any errors that could have occurred? Now, we're going to talk more about the different types of errors here later this week. And are there any further questions? If you were to do this experiment again, how would you do it differently? And that's it. That is the scientific method steps, and this is also the structure of our lab reports. So at the end of our notes now, you're going to want to draw your line across the bottom of your page, and you're going to do the last 2 steps. You're going to come up with 3 questions in green in the margin. Think like you're creating a test question. How would you test somebody on the information we just covered? And then summarize what you learned today. I call it the now I know. And just complete that sentence. Now I know. What did you learn today? Go back to your daily question. Answer that daily question. This should be brief, 3 to 5 sentences. All right, now for your homework. Let me explain what the homework is first, and I'm going to show you some examples. You are going to be creating a mnemonic and drawing a picture for the steps of the scientific method. Now, what's a mnemonic? Well, it's a lot like our RUF, our characteristics of living things. It's where you take the first letter of each step and you create a way to remember what that stands for. And so this is where you get to be really, really, really creative. Now remember, you're going to be drawing a picture to go along with this. So let me show you a couple of examples from students in the past. Now don't pay attention to the letters because the letters represented something a little bit different, but I wanted you to see what a mnemonic looks like. So here's a couple of examples of mnemonics. So for these students, the O, H, E, D, and S stood for something they needed to remember. And then to match their mnemonic, they drew a picture that matched what their mnemonic said. So you'll see oftentimes a mnemonic tells a little story or explains something, even though it's totally silly and may not make complete sense. Now here is my example, and just take a look at what page number this should be on. This is a left-hand side. We took our notes on the right-hand side. Now this is on the left-hand side. So you're going to take the 5 letters, the B, the H, the P, the R, and the A, and you get to be creative with that. So here's my example, and if you want to, you can use my example this time, or you can come up with one on your own. So for me, this is how I remember the steps of the scientific method. Black-haired pirates run away. And that would be a picture that I would draw to go along with it, just to kind of remind myself what the steps are. Now you get to be creative. You can come up with your own mnemonic, something that will help you remember. But don't forget what those letters stand for. B stands for background, H is hypothesis, P is procedures, R is results, and A is analysis. Remember, this is on your left-hand side, and I will check this and your notes for completion in class when I see you the next time.